Okay, so in this paper, the authors discuss a new method of enhanced sampling in molecular dynamics simulations on protein RNA complexes. So they start by mentioning that MD simulations are very complex, very computationally intensive, and that running even relatively short simulations can sometimes take as long as several weeks. So they emphasize that enhanced sampling is necessary because it is the strategic simplification of these simulations. They discuss that enhanced sampling relies on what are called collective variables. So variables are what determine the motion of the molecular system, and these variables can be combined and simplified into overarching or collective variables, and this reduces the data involved in the simulation. Most of these collective variables are based on physics. For example, an example of a common collective variable is using the centers of mass of atom groups as opposed to the individual masses of individual atoms. So they argue that machine learning can be used to find such collective variables, and this is especially useful, even needful, in the cases of very intricate systems with many degrees of freedom, with great flexibility, like protein RNA complexes. So in this paper, they look at a protein RNA complex, specifically one between HIV TAR RNA and the L22 peptide, and they decide to identify new CVs for this complex and test them in a simulation. So to generate these CVs, they use a recently established method called deep TDA, Deep Targeted Discriminant Analysis. So they first conduct very short MD simulations on both the bound and the unbound states of this protein RNA complex, and they use the PyTorch library to identify the CVs that were associated with the motions. The CVs they identified were a nonlinear combination of peptide RNA contacts and RNA apical loop RMSD, things that would not be immediately obvious like other physical CVs. So once they did this, they then conducted a standard 2 microsecond equilibrium MD simulation between the RNA and the peptide, and they observed that, and they simply observed all of the motions that it underwent during this time. They then applied the CVs that the PyTorch model identified in a simplified OPES, which is an on-the-fly probability-based enhanced sampling simulation, and they found that these CVs were able to account very well for the molecular configurations which were seen in the standard 2 microsecond simulation. So they suggest that this indicates that machine learning can be an effective avenue for applying enhanced sampling and making MD simulations more efficient, especially for protein RNA complexes.